These days, almost every four-wheel drive will have a UHF fitted or a handheld unit sitting in the glove box. And not a lot of people give them a lot of thought. They seem like a pretty simple bit of gear. You press the button, talk to your mates, and then they talk back to you. But there's some tips, tricks, and info that you can take advantage of to get the best out of a UHF. So first, let's start with the basics. UHF stands for ultra high frequency, and in Australia that means that your UHF in your four-wheel drive operates between about 476 MHz and 477 MHz. There are some other commonly used radio bands as well. You've probably heard of VHF and HF. They simply transmit and receive at lower frequencies, and as a general rule, lower frequencies means greater transmitting distance. The benefit of UHF with its shorter range is that many more people can use it in different areas without their conversations overlapping. UHF communication is generally limited by line of sight, and while there are different radios with different transmitting power, they more account for obstacles and obstructions rather than actual outright transmission distance. If you can increase your line of sight and decrease the amount of obstructions and obstacles in your path, you can greatly increase your sending and receiving distance. A really easy way to do that is to increase your height. If you're sitting on top of a mountain and your mate's sitting on top of a mountain, you'll have a much greater transmitting distance. Equally, if you're on top of a mountain and your mate's in the bottom of a valley, as long as you can see each other, you'll improve that transmitting and receiving distance. The other thing that affects line of sight is the curvature of the Earth. So if your eyes are about 2 meters above sea level, you can see approximately 5 kilometers to the horizon. If you had a mate over the horizon a further 5 kilometers, although you wouldn't be able to see each other, if you both were using a UHF, the radio waves would intercept. So there's a pretty easy calculation to figure out your theoretical maximum UHF range. That is 3.59 times by the square root of the height in meters of your antenna. So 3.59 times the square root of 2 if it's 2 meters. So if you're sitting in your four-wheel drive on top of a mountain and your antenna was 100 meters high, it would have an effective theoretical range of over 35 kilometers. If your mate was also on a 100 meter high mountain, it'd double to 70 kilometers. But in the real world, you're gonna have obstacles and obstructions, and that's when a more powerful UHF comes in handy. While it's not able to punch through a mountain, a higher powered UHF will have more of a chance of getting through dense bush or foliage. The next important factor that affects your UHF range is the type of antenna you choose, where you mount it, and its gain. In terms of the construction of your antenna, the first type is a whip. That is, what you see is what you get. This part is the transmitting and receiving part of the antenna. The other option is a radome antenna, where the antenna is actually hidden inside a protective covering, generally fiberglass. Now that does minimally affect the signal strength and receiving capabilities, but they're better suited to harsh off-road conditions. The next thing to look out for is whether it's a ground independent or non-ground independent antenna. Now basically, a non-ground independent antenna relies on its base and the surrounding metal area to transmit and receive signals. They need a fairly large, flat horizontal surface to bounce the radio waves. Whereas a ground independent antenna doesn't need that same horizontal surface, and no matter where you mount it, it'll have the same output pattern. The best place to position a non-ground independent antenna is in the center of your roof. If you mount it on the bull bar or to either side of the vehicle, it affects the output pattern negatively. Another thing to look out for is elevated feed. And what that means is that rather than the antenna measurement starting from the very base, it actually starts part way up the full antenna length. So you're getting a slight height advantage and a slight distance communication advantage. Now the most important thing to look for when you're choosing an antenna is the gain, generally listed these days in dBi, which is decibels isotropic. An isotropic antenna is theoretically an antenna with a perfectly spherical output pattern and no gain. So dBi is telling you how many decibels it is above that baseline. While this theoretical isotropic antenna is putting out a perfect sphere, what you're actually getting is more of a donut shape. And as you increase the gain, you're squeezing it down vertically. So it's shrinking in range vertically, but then increases horizontally. So a theoretical isotropic antenna would look something like this. With 2 to 4 dBi of gain, in the real world, this is what you're looking at. Between 5 to 7 dBi, you'd get something like this, and an antenna over 8 dBi would look like this. Each of these different antennas with different gains has their own strengths and weaknesses. So a low gain antenna with its fairly large vertical spread and fairly small horizontal spread makes it ideal in hilly or mountainous terrain. A medium gain antenna adds a fair bit of range horizontally, but loses some of that vertical spread, so it's more of an all-round setup. And finally, a high gain antenna adds a lot of horizontal spread at the expense of any vertical reach. So it's great for flat terrain and getting the maximum distance from UHF in deserts or outback driving. Some units give you the option of multiple different antenna lengths on the same base. And that means you can have one antenna to suit a bunch of different destinations. You can get switches that allow you to connect 2 different antennas to the one UHF unit, but they introduce so many losses into the system that all they end up doing is reducing the effectiveness of UHF radio significantly. Lastly, the coaxial cable that's connected to your antenna is sensitive and needs to be treated with care. You can cut these down to length so long as you make sure you rejoin them correctly. Because if you increase the impedance in this cable, the performance of your UHF will suffer. Similarly, you shouldn't bunch this cable up tightly behind the dash, for example, and it shouldn't be subjected to tighter bends than about 6 centimeters between these 2 points. Now, if you do that, you can damage the internals, which will mean the signals, rather than traveling through the cable, have a tendency to bounce back, increase noise, and reduce effectiveness. One last thing to be aware of, whether you're installing your antenna, sitting in your four-wheel drive using a UHF, or using a handheld, is to try and keep this antenna as vertical as possible. That means that when you're using it, that horizontal pattern is spreading evenly. By changing the angle, you actually change the output direction. Another way to make sure you're getting the most out of your UHF is to understand its more advanced functions. Things like CT-CSS and DCS. Now that stands for Continuous Tone Coded Squelch System, or Digitally Coded Squelch. And they're basically ways that you can use the same channel as a nearby four-wheel driver without being able to hear them. They're a similar system in that they let you choose what could be called a sub-channel within the channel that you're on. If another four-wheel driver has selected the same sub-channel, you'll be able to communicate. Otherwise, both your radios will be muted to each other. With 38 CT-CSS codes and 104 DCS codes, so long as you and your mates have chosen a channel and a code before your trip, it's very unlikely anyone else will interrupt you. Most importantly, you need to know which channel you should be using and when. With modern UHF radios offering 80 channels ranging from simplex to duplex, channels for emergencies only, and for telemetry, it's important you get this right. Simplex channels are the most basic and what you'll most often be using. They're ideal for general chat from radio to radio. Duplex channels extend the range of your UHF by using repeater stations across Australia. A repeater is a special type of radio that receives a signal on one channel and outputs it on another channel. That's why you need a duplex function on your UHF. This duplex function could push your signal a further 80 kilometers in some areas. Channels 5 and 35 are designated for emergencies, while 22 and 23 are for data telemetry. Then there's a couple of other channels like 10, 11, 18 and 40 that have traditional uses, whether that's national parks, convoys, truckies or highways. For an easy glove box guide, check out the downloadable PDF in the description for all the channels. And remember, UHF in Australia is public, which means basically anyone can get on there, transmit and receive, so try and keep it civil. And please stay off those emergency channels unless you need them, because there are big fines for misuse. Remember that families often have the UHF on when they're driving, so watch your language when you're on the radio. And if you're out in the sticks and pull into a little town, don't forget that pubs, servos and houses often have their radios on scan. So don't say anything over the radio that you wouldn't say to someone face to face. As always, make sure you leave a comment if you've got any questions or suggestions, and check out the rest of the channel for more 12 volt, camping, 4-wheel driving and cooking tips, tricks and techniques.